బయట వర్షం వరల్డ్ వద్దునా వద్దురా ఇంత అన్యాయం అయిపోతావురా లైఫ్ లో. నేనే మెసేజ్ పెడితే రెస్పాండ్ అయ్యి ఆయన గురువు నోటికొచ్చాడు అందరం కూడా తీశాడు, బూతులు తీశాడు. అవసరం ఆయన చెప్తే ఆయన గురువునే సపోర్ట్ చేశాడు. తెలిసిందే నాకు చెప్పడం నా తరఫున చెప్తున్నాను. నేనైతే ఆ ప్రశ్న ఉంటే అలా మాట్లాడాలి.
Hello friends, am I audible? Give me a couple of minutes here. I'm just setting up my desktop. Wait for one more minute, guys. Hey, good morning and good evening, friends. Hope I'm audible. Are you able to see my screen? Perfect. So we were discussing about sample mean, right? One sample mean. So how to estimate, given one sample, how to estimate the population sample mean, which means we will be looking at the estimation and then we'll be moving on to the test of hypothesis. In the test of hypothesis, we will make a null hypothesis and we will make the alternative hypothesis, and then we apply the Z principles or whichever the principle relevant to the mean, and then we will arrive at the conclusion that the population mean is going to fall within the range of whatever, whether it is a H1 or a H naught. Okay. So let me give you a little more clarity here. Statistical methods. In this, we have two. In this, we are right now we are looking at inferential statistics. In this, we are looking at two dimensions. One is the estimation. One minute, guys. Guys, give me a minute. I need to take this call. Guru, ఎట్లా అండి ఇంట్లో ఇంత మరీ అసలు ప్రాజెక్ట్ మేనేజ్మెంట్ అసలు జీరో ఎక్కడ ఏమీ చేయలేదు ఈయన. ఇప్పుడు మీరు కదా ఫ్రంట్ ఎండ్ లో ఇప్పుడు కస్టమర్స్ తిట్లు తినేది. అవునా, ఎంత ఎంత అంటే ఎవరికి వాళ్ళు చాలా డిస్కనెక్టెడ్ గా ఉన్నారండి. దిస్ ఇస్ లిటిల్ వరీడ్ బీ. మొన్న 2 years నుంచి నేను జస్ట్ డాక్యుమెంట్ లో నేను అంటే 2 years అయితే ఎవరు ఉన్నారని బికాస్ అన్నాడు. నాకు అవంటారు ఏంది ఓ. బట్ ఎనీవే, నాకు అనిపించింది ఇంత డిస్కనెక్టెడ్ గా ఎందుకు వీళ్ళు, అంటే బేసిక్ గా సీరియస్నెస్ లేదు. అవునవును, ఎంట పడాలి. అవును అవును, కరెక్ట్. నాకు అర్థమైంది వాట్ ఇస్ ద సిచ్యుయేషన్ ఐ విల్ బి గెటింగ్ ఇట్ అనేది. రేపు ఎన్ని గంటలకండి మీటింగ్ ఇది? 11 గంటలుగా నేను జాయిన్ అవుతాను. నేను కూడా జాయిన్ అవుతానండి. నేను ఐ విల్ ట్రై టు కంట్రిబ్యూట్ వాట్ ఎవర్ ఐ కెన్ ఫ్రమ్ మై సైడ్. కరెక్ట్. ఎప్పుడన్నాడు ఐఎమ్ వెరీ బిజీ, ఐ మీన్ దట్ మీటింగ్ అంటారు. కరెక్ట్. ఇప్పుడు అంటే ఇంకా ఏం చేయలేము. ఆఫీస్లో ఉంటే కనీసం అట్లీస్ట్ వెళ్ళి కూర్చోవచ్చు అక్కడ సీట్ దగ్గర. ఇప్పుడు ఏం చేయలేని పరిస్థితి. అది మీరు నాకు ఒకసారి లింక్ పంపిస్తారా? మన ఎరిక్ పంపించింది డాక్యుమెంట్ది, నేను ఒకసారి చూస్తాను ఏంటని. చూడలేదు. అవునా? ఓకే ఓకే, రైట్ అండి. ఎనీథింగ్ గురు? ఓకే, థ్యాంక్ యూ గురు. బాయ్. హలో గైస్, am I audible? Friends, am I audible? Okay, sorry guys, I have to take that call. So as part of the estimation, okay, we will look into two dimensions, right? What are the two dimensions? What is that we look in when we look into the estimations? There are three parts which you look at it from an estimation standpoint. That means you estimate mu, that means mean. Okay, you estimate standard deviation dot the variance. Okay, sigma. Okay, you can say sigma square, which is nothing but your variance, and you also look at the rho naught. This is nothing but proportion. This is proportion. Okay, these are the three dimensions. These are the three parameters you look at it for the population. Right now, whatever we are discussing only this dimension. Which one? This dimension. Okay. So what my plan here is, basically let us continue with the same mu estimation part of it. From there we will look into the other, the test of hypothesis, and then from there we will move on to the ANOVA. Okay. Once we are done with the ANOVA, okay, we will come back and we will learn few mathematical fundamental basics. Then I will introduce you into the mathematical modeling. Okay. So it will take another 5 classes, minimum 5 to 6 classes, my dear friend. I'm giving you heads up upfront so that you will be mentally prepared. Okay. And I will not be sharing this with respect to your sigma square and with respect to the proportion rho naught. Okay. What I do is I will create the videos. Okay. I will share the videos with you so that you can listen at your own time. It is okay, so that I don't want you guys to miss the timeline. Okay, so I said within 40 to 45 classes I will complete the whole thing. Will be delayed by, these are the, here I need at least 2 classes. I need this one, I need 1 class. So these 3 classes probably I will create the videos or audio file and I'll share it with you so that you can go through at your own page. Right? Will it be okay? Okay. Now coming on to the test of hypothesis perspective, there are 3 dimensions here. There are 3 dimensions. Can anybody think of what are those 3 dimensions here? We will be looking at here also the same story. We will be looking at one sample. You will be looking at 2 samples. You will be looking at more than 2 samples. Okay. Somehow my mouse is not working. Okay. So let us give a little more deeper into this. So for all these three types of business problems, you will be estimating these 3. Please remember, for all these, you will be estimating these 3 parameters. They are the important parameters for the population. So when I look at the one sample, okay, when I look at the one sample, you have 3 dimensions. That means one is I will look into my mu, I look into my sigma square, I look into my proportion. When I am looking into mu, depending upon my n value, I will take the help of G tables. If n is less than 30, I will be taking the help of T table. If n is greater than 30, I will be taking Z tables. Okay. When it comes to this sigma square, that is when it comes to the standard deviation or the variance, we will be using basically something called chi-square distribution. This is a Greek word, chi-square distribution, which you will be looking at. This is the chi-square table you will be looking into it. This is the symbol for that. Okay. And when it comes to the proportion, again it is a straightforward simple. You will be using Z table. Okay. So these three dimensions or these three parameters that you will be looking out for one sample test of hypothesis. That means when you are writing your H0 or H1, you will be dealing with these three parameters, mu or sigma square or rho naught. Okay. But when it comes to the two samples, again the same story, but only difference here is here you will be using mu1, mu2, sigma 1 square, sigma 2 square, rho naught prime, rho naught 1, rho naught 2. Okay, and all these applicable, zt, chi square, z are applicable. They are the same. They are the same. Okay. Oh, more than two samples. If you are trying to consider more than two samples, you will be using a technique called ANOVA. It is also called as very popular analysis of variance. Okay. We need to be very, this is invented by a guy called Fisher. It's also called Fisher analysis. This is developed by Fisher. And we all need to be very proud, guys. There is one mathematician called Indian father of Indian mathematics in nowadays, in the modern times, is Dr. C.R. Rao. I think last year he passed away. Amazing guy. Amazing means amazing person. Okay. So he is one who has actually done a lot of work over here. Okay. So here, what is that here we are trying to do? We are from one sample, we are able to estimate population parameters. If you have two samples, you are able to estimate population parameters using this fashion, using these parameters, using these metrics. But when you are using more than two samples, you will be adopting ANOVA. But you don't need to worry about it when you are doing the whole thing in R and Python programming, because simply typing ANOVA command, it will does the job for you. But what is ANOVA? It's a wonderful, beautiful, in-depth concept which I will be taking you through tomorrow. Okay? But today I'm not going to talk about the ANOVA, but I'm trying to give you, I will just make you ready for ANOVA for tomorrow's class. Okay? Going on. Now, we have seen so far how to do the estimation of population parameter mu, which is my mean, population mean from the sample mean. From the sample mean, we know how to estimate the population mean. Now let us look at two sample comparison. It's called two sample comparison. The subject is too deep, guys. Okay. Suppose you have sample 1, you have sample 2, because in real world you have a choice of how many samples that you wanted to take it, right? For that matter, for any business problem. Okay. So generally two samples will always gives you a little more comfort compared to one single sample. In such a situation, there are few dimensions here. For the sample 1, you have your average, which you have your mean, your average. Okay. But population parameter for the here I'm calling it as, sorry, from the sample here I'm calling it as the mean as mu1. For this, I am calling the mean as mu2. Similarly, it is sigma 1 square. This is sigma 2 square. Third one. Okay. This is rho 1. This is rho 2. So now we are considered only with this point. So let us look at it, how our test of hypothesis is going to deal with when you are using two samples. When you are using two samples, how will be my test of hypothesis? Okay. In test of hypothesis, we have seen three dimensions, three variations which we have seen it, right? We have seen a manufacturer view, we have seen an engineer view, we have seen the, okay, what do you call, the consumer view. So generally you will have three views in the test of hypothesis for every problem. Okay. So you have H0, H1 for the first view, then you have second view, then you will have third view. Let's look at this. If I have two samples, okay, there are two scenarios. There are three scenarios. What is those three scenarios? First one, H1, my mu1 is not equal to mu2. So obviously your H0 becomes mu1 is equal to mu2. This is the case 1. Case 2, my H1 will be mu1 is greater than mu2. That means obviously mu1 is less than or equal to mu2. Third case, what is the third case? Mu1 is less than mu2. That means obviously mu1 is greater than or equal to mu2. That's all, guys. That's all you have to do. So in other words, what you have to do, in other words, I can also write the same above statement, something like this. Let me change this here. This H0, mu1 minus mu2 equals to 0. Mu1, H1, mu1 minus mu2 is not equal to 0. This and this are same, guys. Please remember, they are talking about the same information. Similarly, here H0, I can write it as mu1 minus mu2 less than or equal to 0, and my H1 is mu1 minus mu2 is greater than 0. Same case here. My H0 is mu1 minus mu2 greater than or equal to 0. H1 is equal to mu1 minus mu2 less than 0. So they are same from the two sample mean perspective. That means everything you work with mu2 two means, and then you try to estimate the population parameter from these two means. Okay, guys. Any question? I will pause it for some time here. Please. Is that clear to you? Friends, everyone please respond. Any questions here, or is there any confusion? So I will tell you how this is going to be applicable. Arvind said not clear. Arvind, you are not clear, right? Okay. So, okay, let me give you a little more insight. Maybe we can give you some more formulas here so that you will be clear. Then you will understand this. So your concern will be, now I have two mu one and two averages. If that is the situation, how do I calculate my z? That may be your question in your mind, right? How do I calculate my z when I have two mu one and mu twos? How do I calculate whether it is g or t, whatever it is? We are not talking about chi-square because right now we are talking about only mu. Okay, so let me give you a small derivation perspective. What is the g formula? X bar minus mu by, right? What is the formula here? And you can even tell me. I can also write this as a square root of variance of x, which is not sigma by root n divided by n, right? This is sigma divided by root n. You are going to put it here. That is nothing but your variance, guys. So this is in case of one sample. That means if I have one sample, so I can use this because I have one x bar. Now I have two samples. What should I do? Very simple. x1 bar minus x2 bar. This is one x bar. This is x1 bar minus x2 bar minus mu1 minus mu2, mu1 minus mu2 divided by square root of my sigma 1 square by n1 plus sigma 2 square by n2. This is the formula, guys. This is how you calculate your z when you have two samples. So now from the sample, now when you have the z values, you from here you estimate your population parameter. Estimate population parameter mu. This, okay. When you are estimating this population parameter mu, again the same from the test of hypothesis, whatever we have defined on the top, the same story will be applicable over here. Is it clear now? I'm trying to connect the subject which you have already learned. I did not repeat what is that we have learned so far behind. Okay. Arvind, fine, you're okay? Okay, let me give you the some formulas here, so that will help you. Okay, that's why I feel very difficult to cover it in one class, guys. This actually takes 3 to 4 hours class to basically compute the, to give a wonderful clarity to you, but I will try to do my best. See here, let us make a table. Okay, so okay, this is for two sample. From the two sample, you are comparing the means and trying to arrive at your population parameters. Right now, I'm focusing on mean. The first condition here is there are two samples. That means my N1, that means the size of the sample 1 is greater than 30, and this is also greater than 30. The size of the second population is also greater than 30. Here, my standard deviation sigma is known. That means for some reason you know the value of the sigma for the population. This one unknown. Guys, please write down these formulas. There is a huge science behind that, but you need to remember these things. If you remember, you will have a different confidence. If you don't remember also, in Python and R, you will have some commands you need to remember. That is good enough. But my suggestion, remember these things. When sigma known means what? That means you know sigma 1 and you know sigma 2. Unknown, you are not aware of what are the values of sigma 1 and sigma 2. So in such situation, how do I calculate my z? Simple. x1 minus x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 square by n1 plus sigma 2 square by n2. This is the formula. Now there is another scenario where n1 is less than or equal to 30 or n2 is less than or equal to 30. In such a situation, this is same. That means here the only difference here is instead of z, you will be using t. Here you are using the t table because n is less than 30. Here you are using z, but the formula will be the same. The values will vary from the table perspective. Okay. So moving on to this, when sigma is unknown, that means standard deviation of your population is unknown. So what I'm saying is z equals to x1 minus x2 minus mu1 minus mu2 divided by square root of, you are using sample mean. S1, S2 are nothing but sample means, guys. That means whatever the sample you have it, the same sample standard deviation you are using. Any question here? Any doubt here? Please ask. Otherwise, I do not know whether you are really understanding or not, or at least respond. Guys, this is the only little bit formula part, guys. Rest of the very, very simple. Just you need to remember, you need to by heart these formulas. That's all. Nothing much. In case of here, in case of the second situation, sigma unknown, there are two cases. Case 1. What is the case 1? What is my H0 here? In the case 1, I am accepting my H0. So this is test of hypothesis is, so test of hypothesis here is going to talk about whether sigma 1 equals to sigma 2. Or you can say sigma square. This is what test of hypothesis. That means though it is unknown, your assumption here is, okay, the standard deviation of the sample 1 population part is sigma 1 and the standard sigma 2 is nothing but the standard deviation of the population of the sample 2. Okay, so in such a situation, I will be using the t parameter here. See, it is t only. G is not, this is not z, this is t here because n is less than 30. So now the formula here is x1 minus x2 bar minus mu1 minus mu2 divided by square root of sp square into 1 by n1 plus 1 by n2, where your sp square is called pooled variance. Guys, I'll pause for a minute so that you can write down in your notes. This is important. Please write down, or at least you can take the screen snapshot so that you can try it out later. Print screen. Use the print screen. Copy this into your Word document. You open up a Word document. Test it there. If you are making notes, wonderful. Done? Please respond. All of you, are you done? Do it, Kritik. Write down. Did you complete, Kritik? Okay, I'll move. How do you calculate this pooled variance? Your pooled, what there is a formula for your pooled variance. Okay, what is this formula? This is nothing but n1 minus 1 multiplied by s1 square plus n2 minus 1 multiplied by s2 square divided by n1 plus n2 minus 2. Okay, this is nothing but this is your degrees of freedom. Okay, so this is something like this. If I try to look into this, this is one dimension. This is the another dimension. So this you call it as W2. This you call it as W1. So what is that it is doing? Basically, it is what is it is doing? It is actually calculating the variance in a weighted average perspective. That means because there are two samples over here, this n1 minus 1 divided by your degrees of freedom will basically giving you a weightage of weightage. Accordingly, you are using the first sample's standard variance, standard deviation or a variance. Similarly, here you are using the second one. Okay. This is mainly because then what is this n1 minus 1? Again, it is actually, if you look at the S1, there is only one constraint. If you look at the S2, there is another constraint. So the degree of freedom will be, there are total two constraints you have. So degree of freedom is n minus 1. By default, we define it, right? Degrees of freedom. So this here n is nothing but 2, n1 plus n2. Okay. And because there are two constraints, so this is actually the constraint. So n minus 2. That is how the degrees of freedom has come. We have arrived at over here. Please understand this. Again, the same fundamental, same principle is applicable what we have learned earlier. Okay. You may not like it or you may not understand what is this, how suddenly these numbers, these formulas are coming up and all that. Don't worry. Just you need to know this. That's all. But most of the time your program will do this job for you. I'm not getting into your derivation of all these things and all that because that will make you crazy. You go crazy. Okay, that is case 1. Case 2. What is case 2? My test of hypothesis is going to be something like you are accepting H1. You are accepting H1. What is this? Sigma 1 not equal to sigma 2, or sigma 1 square is not equal to sigma 2 whole square. So in such a situation, you will be using this formula x1 minus x2 bar okay, minus mu1 minus mu2 divided by square root of s1 square by n1 plus s2 square by n2. This is the formula, and you need to calculate whenever you get into the t tables. You need to calculate the degrees of freedom. That is why I'm specifying the degrees of freedom even above and below. Without degrees of freedom, you can't go and find the value from the t tables, right? So your degrees of freedom will be something like this: s1 whole square by n1 plus s2 whole square by n2 divided by this is the whole square divided by s1 square by n1 whole square divided by n1 minus 1 plus s2 whole square by n2 whole square by n2 minus 1. Don't worry guys, don't bother about, don't get scared of all these formulas. Okay friends, are you with me? I'll wait for some time so that you can copy this, you can write down these formulas. So today's class is the only class which will create a little bit of confusion, guys. Otherwise, uh, again, when you get into the ANOVA or when you get into the modeling and all that, it will be very interesting. Because now you have all necessary ingredients. You have all necessary ingredients to actually get into the data science. Now we will talk about data science. So far what you have learned is you understood what data means. You also understood how the data is evolved from a simple static data to the dynamic data, from the dynamic data, how the data has become big data, right? From once you know the big data, then any organization having any data, deriving the intelligence which is not identified, the business intelligence tools, is the job of a data scientist. Okay, that is the small thin line of difference between BI and data science. Because most of the time people argue, making a statement saying that BI is nothing but data science is the one level above the BI. Definitely agree, no doubt about it. But BI will be more focused on reporting and trying to derive some intelligence out of the existing data, okay, which is pretty much visible. Whereas the data science is a science which derive the intelligence or derive the hidden information sitting inside the data. When we are trying to derive the intelligence sitting inside the data which is hidden, you need to understand the data very well, number one. Number two, you need to figure out how the data is actually distributed. What is the data, which distribution the data is belonging to? Because you are trying to map the existing data of any company into the various distributions that you are aware of, whether it is a normal distribution or a Bernoulli distribution or some other binomial distribution. There are so many distributions are available. Now you map them onto the normal distribution, and from the normal distribution you look into your descriptive statistics. Using the descriptive statistics, you will figure out, you will plot the pictures, you will represent the data into the pictorial representation. Then you will try to do exploratory data analysis, and then you will try to figure out how the data is going to look like and what it is, blah blah blah. So you will have some kind of an understanding now. After that, now you got into the discussions about how do you estimate the population parameters given the samples, one sample or two samples. If it is more than three samples, that's where we will get into the ANOVA part. So having this dimension which you are aware of, and looking into mean of one sample, looking into sigma square of one sample, looking into proportion of one sample versus two samples and three samples, two samples and about two samples, is put together considered as the fundamentals of data science. That means you need to really understood these dimensions before you actually start getting into the data science, right? Here we will be in the data science, we will be talking about, okay, after ANOVA, or I can take a relaxation of ANOVA. Let me complete the ANOVA tomorrow. It will take maybe 2 classes. Then I will be again taking you to the few fundamentals. Okay, what is that? Whatever required matrix algebra, which matrices algebra. Okay, I will cover little bit of coordinate geometry with those two dimensions, with the coordinate geometry, matrix, and a little bit of calculus where you need to know d by dx, and you need to know dou by dou x. Okay, so this we will cover in 2 classes. This I will probably take 2 classes or maybe 1.5 class, and another half class which we will be executing the same thing using your R programming. Okay, after this I will take you into data modeling. Okay, In the data modeling, I am going to getting into simple linear regression and multiple linear regression. Completely we will be using the R programming. Completely we will be using the R programming. No more Excel, no more Minitab, no more anything else. Okay? We completely use R programming and do it. Guys, this itself will take minimum 4 classes. I actually generally I teach this simple linear regression for 18 classes. Simple and these two because there are many dimensions. If I explain all those dimensions in this 18 classes, right? After that, getting into your random forest, getting into logistic regression, getting into your decision trees and neural network, whatever deep learning, whatever, it becomes so simple. Support vector machine, principal component analysis. So that is how that much of depth I will go here in 18 classes. But given the situation, what I promised you guys is I'm going to cover it up 4 classes, where I will be giving you high level overview of how this modeling is going to be done. With that, you will have you will be ready for your machine learning course. Then you go and join many machine learning course. I can guarantee you will do wonders. Is that okay, my dear friends? Okay. So I'm happy. At least we started with some 20 people or whatever. Finally, I see only 7 or 8 people over here. I'm happy. At least 7 people are really till the basics I covered till now. Okay. And once you get into the simple linear regression, you will have utmost clarity of why we have done all that earlier. Okay. There is some from what do you call some amount of R when we'll take up a case study, small case study. I will show you with the case study. With the case study, I will explain these simple linear regression and multiple linear regression. Okay, then you will understand how to take a business problem and provide a solution to the business problem. I will tell you upfront the business problem. So there is a car manufacturing company. Now this company wants to manufacture a car which can fit into, or which can become a bumper hit in, let's say, American market or maybe Indian market. So car company wants to do that study well in advance, and they wanted the data scientist should give the recommendation of how is going to be the price of the car and what are the various features that the car is going to contain. You are a data scientist and you are going to solve this problem. Okay. The question starts with, now after that you will be thinking about where I should get data. What data first I have to collect? That's the question. From there we will start. Then you will have a complete clarity about, oh, this is what the data scientist job is. Till then, you might have heard here and there, you might have saw some here and there, but you will not get the handle around it till I show this case study. Okay, I am sure after the case study, you will walk out of the class with the utmost clarity that, okay, now I understand what data science is. Okay, guys, any question? So you need to next 6 months, coming 6 months, guys. It's a difficult time for everybody. Many people are losing jobs in the market. Okay, especially Probably people who are coming out of engineering colleges will have a little bit tough time. But we are hoping that within 6 months time frame things will little bit recover or improve, because the recession is going to be there till November 2021. That means basically this year and next year, 2 years, we will have the recession, which will have an impact on job market for many companies. Okay, so it's an opportunity. One way it is an opportunity. One way it is difficult time. But don't stop learning. Keep on learning. Keep on learning. Keep on learning. Go and learn things. Add yourself. And my one more suggestion to all of you: learn parallelly Java. If you don't learn Java, let me tell you, you will become a handicap in the whole industry. I don't know, somehow people pick it up this notion saying that, okay, can't do coding in Java, let me go to Python, let me go to R, it is very simple. Okay, but if you don't know the Java, you will be in trouble. Okay, so parallelly along with Java, you need to now when I'm saying you are a data scientist, you need to have a good handle or a control on SQL, structured query language. If you don't know the SQL, what data you will pull from the databases, right? So SQL, you need to master SQL. If you are a fresher, if you want to get into the data science related job, then many questions will be asked. You need to go through a SQL exam first. Then only they will talk about all these principles or these questions related to the data science fundamentals. So if you don't know the SQL and if you want to become a data scientist, forget it. So my suggestion, practice your SQL a lot, especially you need to write many joins, inner join, outer join. You need to master these things in SQL. Without SQL, you can't even get into a data engineer job. Okay. You need to have data engineering SQL knowledge, and then you need to be good at your analytical skill, because there will be another exam they will conduct on the analytical skill. Same GRE, TOEFL, GRE, whatever you will be writing, right? Same questions will be asked. You need to good at that. Then only this third dimension will be touched upon in the interviews. Okay. If you are get selected in the campus itself, you are lucky, because you will bypass all these things, because they will say, okay, we will give you the training. But if you miss the campus interviews in the colleges, you have to go through SQL and analytics question paper exam, followed by interview, where they will be asking you these questions, whatever that I taught you so far. Okay. Nobody bother about whether you got R or Python. If you have these two languages, it is a big advantage for you in the interview. Okay, guys. Hope I have given you that and try to paint the picture that you are getting into after your engineering. Okay, nothing to worry about it, but this is the reality. Accept the reality and strive yourself how you can do better in the subject. Okay, friends. So with that said, I'll stop today's class. Catch you guys. By the way, tomorrow shall we have the meeting? Yes, I think tomorrow we will have the session. Yeah. Okay, everyone. Is that okay tomorrow, or you want the day after tomorrow? Shall we have a session tomorrow? Ramya said yes. Ravi said yes. Others still thinking? Okay, let's do session tomorrow, ANOVA, same time. Okay, thank you.